Hi everybody, today I'm going to do some examples of proof by contradiction. We'll do a step-by-step exploration of this indirect proof method. Let's start by talking about what we mean by proof by contradiction. To prove our statement P is true, we're going to assume it's false, then show that this assumption leads to a logical contradiction, meaning something that can't be true. The reason why this works is that if we assume not P leads to a contradiction, then not P has to be false, which means P must be true, since P and not P always have opposite truth values. Our first example problem says, if the sum of 5 integers is 21, then at least one of those integers is greater than 4. To prove this statement, we're going to assume the negation. And notice what we're going to negate is not the sum of the 5 integers being 21. We want that part to be true. What we want to negate is that at least one of the integers is greater than 4. So we'll assume that none of the 5 integers is greater than 4. That is, every integer a sub I is less than or equal to 4. Now we want to work on deriving our contradiction. We start by saying each of our AIs is less than or equal to 4. Since we have 5 numbers, that's A1 plus A2 plus A3 plus A4 plus A5. Since each of these numbers is less than or equal to 4, we note that their sum has to be less than or equal to 20. And this is the contradiction. We started by saying the sum of these 5 integers is 21. But our assumption forces the sum to be at most 20. Our assumption led to a contradiction, therefore at least one of the 5 integers must be greater than 4. Problem 2 says an integer n cannot be written in the forms 4k plus 2 and 8l plus 1. The idea here is that we can write n in both of these forms at the same time. To do the proof, we will assume the negation. That means we're assuming the contradiction. There exists an integer n such that n is equal to 4k plus 2 and n is equal to 8l plus 1 for some integers k and l. Now we're ready to derive our contradiction. We'll start by setting 4k plus 2 equal to 8l plus 1. We can rearrange that, bringing the variables to the left and the numbers to the right. We have 4k minus 1 is equal to 1 minus 2, which we'll write as negative 1. 4k and 8l are both even, so let's factor out a 2. Now I have 2 times 2k minus 4l is equal to negative 1, and that causes our contradiction. On the left, 2 times 2k minus 4l is even. I have a factor of 2. But on the right, I have negative 1, and I know negative 1 is odd. The contradiction is that we have an even equal to an odd, and we know that that can't be true. An integer can't be both even and odd. So our conclusion says no integer n can be expressed in both the forms 4k plus 2 and 8l plus 1. There are a few key takeaways I want you to remember when you're doing proofs by contradiction. The first one is that we negate first. We always start by clearly stating the opposite of what you want to prove. From there, you're going to use known facts, and these facts are going to change along with the problem. So you might be using arithmetic or algebra or maybe some properties of integers to derive your contradiction. That's the hard part, is figuring out which facts you need to use for the proof you're trying to do. From there, you want to find the impossible, so you're looking for results that don't make sense, like an even being equal to an odd or a sum that exceeds a known bound. Once you reach a contradiction, the original statement is proven to be true, and you can state your conclusion and wrap up the proof.